Okay, so I'm going to do another combustion analysis video. We're going to find the empirical formula from a combustion analysis. If this one's better, I might just delete the other one. Okay, so here's what we got. Upon combustion, a compound containing only carbon and hydrogen produces such and such. Okay, so upon combustion, we get this. So let's look at this again here and just remind ourselves how this works. This goes like this. Oops, well, let's get a different color. Upon combustion, so we've got this C, and it says only C and HM. It combusts. Okay, we're going to combine it with oxygen, and it produces carbon dioxide and water. Okay, so I'm going to do carbon and oxygen there also as a table. So this is the balanced reaction, but I'm going to use this as a table where these are my column headings. Okay, so mass, formula weight, moles. We'll do this. Don't forget now, this mass is in grams. Grams per mole and moles. Okay, so let's go back to the question again. It weighs 3.02 grams. And it produces, 3.02 grams of carbon. Okay, that we don't know how much it weighs. 3.02 grams of that and 1.24 grams of water. 1.24 grams of water. 3.02. Let's erase this. Bam. Okay. And that means the mass of this, of course, the sum is the sum of the carbon and the oxygen. All right, so what's the formula weight of carbon dioxide? It's 44.01. We just did this in a previous video. Something new. I don't want to take time in this video for that. I'm trying to keep things simple. So the moles then is going to be 3.02 divided by 44.01, which is 0.0686. Okay, and the formula of the weight of this is 18.02, and so the moles of that is going to be 1.24 divided by 18.02. It's going to be 0.688. Okay, that's the moles. Now, how many moles of carbon do we have? Right, it's going to be the same because it's a 1-to-1 ratio. 0.0686. Oops, this wasn't supposed to be oxygen, this was supposed to be hydrogen. Okay, because all the oxygen comes from here, right? So we don't need that oxygen. Now, this is something I can't do in my head. I'm going to go to a separate sheet of paper. Bam. Let's get rid of that. Moles. No, let's do this in red, different color. Moles of H2O right? 2-to-1. I don't remember what that number was. Oh, I have it here. It's 0.0688 times 2 is going to give us 1.376 moles, or 0.1, sorry, 0.1376 moles. Let's go back to it's going to give us 0.1376 moles of hydrogen. Okay. Now, so our formula, we basically are done with our formula now, right? It's going to be 0.0686 hydrogen, 0.1376, but we can't leave those as decimals, right? So let's divide both of them by the smallest number. This is going to go to 1. And this is going to go to, what's 0.136, 1376 divided by 0.0686 goes to 2.006, which is essentially 2, right? So the answer here is C1H2, which is really CH2. That's the empirical formula for this guy here. So a little bit shorter, fewer things to deal with. We didn't have to worry about extra oxygen in there. That's why this is a simpler question. So I hope this is helpful, and please let me know what other questions you have.